All right, so on this little practice exam, it's kind of review for exam 2. Remember, exam 2 covers modules 3 and 4. And on this, we are going to do a ton of factoring. All right, factoring everywhere. You're going to have to factor on almost every single problem. So if you've still been struggling with factoring, please, 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 do more practice with it, because if anything's going to help you on this next exam, it's being able to factor, know how to factor, but also if you can kind of get a little bit faster at factoring, that will help too, right? Just to make sure that, the 2 hours that you have to take the exam, you'll be able to complete it in time. Okay, so this first question here is properties of exponents. And so we need to make sure that we remember how to do these properties of exponents. So I'm going to just show you here how I would do it. So when I see that I have a negative on the outside, I like to flip everything that's inside so that I can make this outside exponent positive. So when I do this, right, so everything on the top, just the way it is going on the bottom. So I'm putting 2 x to the negative 3. I'm not changing that negative yet. Okay, so leave that as negative 3 and y to the 4th. And then on the top, whatever the bottom is, just like it looks, 3x to the 3rd, y to the negative 2. And now this is all raised to the positive 2 power, right? So all I changed from this first, or to get to this first step, is just flipped everything inside and made that outside exponent positive. Okay, now I don't like working with negative exponents. So now I'm going to flip everything inside so that they are positive. They're happy, where they're at, whether they're on top or bottom. So I can see that that 3 is perfectly happy to be there. That x to the 3rd has a positive exponent, so it wants to stay, right? But that y to the negative 2 wants to go downstairs. Okay, but let me write down here the stuff that wants to stay in the bottom. So 2 and y to the 4th, right, are going to stay where they're at. So I'm going to take that y to the negative 2, flip it downstairs, and it will be y to the 2nd now, right? Change that negative to a positive. And now I need to flip that x to the negative 3rd upstairs to be x to the 3rd. And then this is still all raised to the 2nd power. Right. Now for me, I like to simplify the stuff that's inside first before I distribute that power of 2 to everybody, but you can do it either way and it's going to give you the same answer, right? So I'm going to choose to simplify what I have inside here. So 3 and 2, that fraction won't reduce, but if it would, we'd want to reduce it, right? So I have just 3 and 2 there. And now I'm going to combine my x's together, right? And so when these are combined, if they're connected by multiplication, I add those exponents together. So 3x to the 6th is what I'm going to have there. And then on the bottom, 4 plus 2 is also 6, so y to the 6th. And now I'm going to raise everything to the 2nd power. All right, so my coefficients need to be raised to the 2nd power as well as my variables. So 3 to the 2nd power is 9. 3 times 3 is 9. X to the 6th raised to the 2nd, right? So when we have a power raised to a power like this through these parentheses, we multiply those together. So that's going to give me x to the 12th. And then on the bottom, 2 to the 2nd power is 4. And then y to the 6th squared is going to be y to the 12th. And then that will be your answer. That's how you leave it. Okay. All right, on this next one, to factor this polynomial, I have my leading coefficient is 1, and I see I have a trinomial here, and so I can actually go straight to my parentheses, which I call hippobutts. All right, so when I'm thinking about it, I'm saying, okay, what times what is m squared? Well, I'd have to have m times m. And then what times what is 24, right? So what multiplies to be 24 that adds to be negative 11? Can you guys think of what that might be? What can we think of? What multiplies to be 24? So I've got 1 times 24. I've got 2 times 12.
8 and 3.
Yeah. Got 3 times 8 and 4 times 6. All right. So if you work organized like this, then it might be able to, you see better. And so 3 and 8, but both of them need to be negative in order to add to be negative 11. So I'm going to have m minus 3 in one parenthesis and m minus 8 in the other parenthesis. And then that is done. Okay, but again, it's fast because our leading coefficient was 1. Right, down here on number 4, we're not going to be able to, do it quite that quick there. All right, but let's look at number 3. This time we have 4 terms. And I said before, like, if you have 4 terms, that means you're going to be doing factor by grouping. So to do that, we first want to look and see if there is a greatest common factor of all 4 terms. And there's not. So then we split it in half and we find the GCF of the first 2 terms and then the last 2 terms. All right, so when we do that, let's see, I'm going to choose a blue color here. Hold on a second. Maybe I'll choose purple. I don't know why it's not doing it. Okay, so what is my greatest common factor between 16x squared and negative 40xy? What's the biggest thing that can divide into both?
4x.
Yep, 4x will, but there's one number bigger than that can go in. What else besides 4? Yeah, so 8x. That we need to have there. Because if we did the 4, then we'd still find that we had something in common that we could take out more. So yeah. All right, and then if I divide each of these parts by 8x, then I'm left with 2x here. And on that one, I'm left with minus 5y. Okay, now let's look at the second part. What is my greatest common factor of 2x and negative 5y?
Nothing.
Yeah, so if we can't find anything, that means that 1 is what we need to use as our greatest common factor. 1 can divide into both of those, but that is the biggest number that can. And then we still have that 2x minus 5y in parentheses. All right, and now we notice, oh, these guys are exactly the same, which is what they need to be in order to do this factor by grouping. And so the common factor goes in one parenthesis, the 2x minus 5y, and then the other parenthesis are leftovers. 8x plus 1 goes in the other one. And so that is now in factored form. Okay. All right, let's keep looking at more factoring here. So on this one, our leading coefficient is not 1. So we've got to look at this a little bit differently. And we've got to think, okay, I've got to multiply these two numbers together now, the first and that last number. So 6 times negative 3 is negative 18. So on this one, I'm trying to think what multiplies to be negative 18 that adds to be 7. All right. And so again, if you like list out all of your factors of negative 18, well, I just do like 1 times 18, 2 times 9, 3 times 6, and that's all of them. And then I can see, all right, my winning combination is 2 and 9, but in order for it to add to be negative 7, 2 has to be negative. All right. Okay, so now this is the part that most people forget to do on this. We can't just take that negative 2 and 9 and put it in kind of like we did up here. All right, we're going to make a 4-term polynomial. So now I'm going to keep that first term, that's 6x squared, but my 7x is going to be split up this way that we just found with the negative 2x, right, and then the positive 9x. All right, because negative 2x plus 9x gives me that 7x, but I need it split up like this so that I can write this 4-term polynomial. And now it's just like the question that we did above. All right, so we're going to split it in half here. And then let's see what we have. Our greatest common factor of those first 2 terms is going to be 2x. And when I divide each part by 2x, I'm left with 3x. And then this one sometimes tricks people, right? Negative 2x divided by 2x is minus 1. All right, now let's look at the last 2. Our greatest common factor with 9x and negative 3 is going to be a positive 3. And when we divide each of these by positive 3, we're left with 3x minus 1. Okay, and again, we can see, all right, that's my greatest common factor, so that goes in one parenthesis. And then 2x plus 3 goes in the other one. And that is my answer. All right, you guys doing okay so far with the factoring? Questions there? All right, speak up if there are questions. Okay, on this one, this is a difference of squares. And I sent you guys an announcement earlier today. And so it's week 8 announcements that I'm referring to. And I told you on there, you really need to memorize a couple of things for the factoring. One of those is what the difference of squares is, like how that factors. And the other thing is making sure that you know how to do the sum or difference of cubes as well. And I think it's a good idea, like have those memorized, and then when you get to the exam, just write them down at the top of your exam so you don't, accidentally get something mixed up in your head while you're working on other problems when you're doing the exam. So remember, our difference of squares, we start off with something like a squared plus b squared. That's going to be a plus b times a minus b. That's how it factors. All right, so understanding that is going to be important. And then I'm also going to write up here the sum and difference of cubes. So if I have a cubed plus b cubed, that's going to factor to be a plus b, and then a squared minus ab, and then plus b squared. And then our difference of cubes, a cubed minus b cubed, really similar, but this time I'm going to have a minus b, and then my next one I'll have a squared plus ab, and then plus b squared. All right, so make sure you have these memorized for the exam, especially on the cubed ones. You're really going to be sunk unless you have these memorized. And really remember, the only thing that's different about these are the signs. And so I said, make sure to remember to use SOAP. That stands for same, opposite, always positive. All right, so if I check that I'm using SOAP, well, here was a minus, so my first sign here has to be the same as that. Then my next sign is going to be opposite of what it was, and then the last one is always positive. All right, so that's kind of how you can double check that you have those signs correct on it. Okay, so on number 5, when we're doing this one actually factors pretty nicely, pretty easily here. All right, what times what is t squared? Well, t times t. And then remember, according to this, right, 49 is not my b. Right? I can write 49 as 7 squared. And so remember, that is what I'm going to have what I kind of need to think of it as, because 7 is my number that's going to go in here. So I'll have t plus 7 and t minus 7. The other way you can think about it is what multiplies to be negative 49 that adds to be 0, because we don't have a t term in the middle. Right? So that's another way you can think of it, where you don't have to have this memorized up here if you know that other way. Okay, so now we have a difference of cubes. So we're going to be using this top one here because it's connected by addition. So probably the trickiest part, the part that people forget, is that 27 is not our A and 64 is not our B. We need to rewrite this so that it is something all cubed plus something all cubed before we can write out how it factors. So when I look at this, right, 3 cubed is 27. 3 times 3 times 3. So 3 needs to be in here, and then x times x gives me my x cubed. So 3x is going to be what I call that A part of what I'm doing on here. And then 64, 4 times 4 times 4 is 64. So that, the 4, is going to be my B. All right? And so once I've found what my A and my B are, now it's just a matter of kind of using this formula to plug that in to see what we get. So right here, right, so I'm saying I need to do A plus B. So in this case, it's going to be 3x plus 4. And then in my second parenthesis, I'm going to follow this, A squared. So 3x all squared. So be careful with that, right? So I'm going to put it up here. So 3x all squared, right, is not the same thing as 3x squared like this, right? And we want the 3x all squared. And so that means we're going to have 9x, because 3x times 3x is 9x squared. So that's what we need to have here, is a 9x squared. And now we need to do minus A times B. So let's put our subtraction sign in here. And then 3x times 4 is 12x. And then our last one, we need to take our b and square it. So 4 squared is 16, so plus 16. And then let's make sure that we use SOAP, all right? That same opposite always positive. So it started off with plus, so I should have a plus in that first sign in between, then opposite of it, and then the last one there is always positive. So I can see, yep, followed that, and so that is how it factors. Okay. So speak up if you have any questions, otherwise I will just keep going here on this. Okay, so on this next one, when we're asked to solve a polynomial where we don't have just a t term, we've got like a t squared term or an x squared term, right? Something squared. We can't solve it in the same way that we do if it was just a t. So on this one, remember we have this, we're going to have to get everything over to one side and put the other side equal to 0 because we have to factor to solve this, right? So like I said, if you're not factoring on almost every single problem, you're probably doing something wrong. Okay, so on this one, I'm going to start by subtracting my 21 over, so that's going to give me t squared minus 4t minus 21 equals 0. And now I need to factor that to solve it. So let's see, how is this going to factor? So we got t times t is my t squared. What times what is negative 21 that adds to be negative 4? What that is, we're going to have 7 and 3. 7 times 3 is 21, but one of them needs to be negative in order for it to be a negative 21, and since we have a negative 4 in the middle, that means our bigger number needs to be negative there. So we're going to have t minus 7 times t plus 3. Okay, now don't forget, it's still equal to 0. Sometimes students stop there and think they're done, but you haven't solved it yet, right? We factored it, and that helps us solve it, but we haven't solved it yet. So now set each of those parts equal to 0 and solve, right? So I have t minus 7 equals 0, and then I have t plus 3 equals 0. So if I add the 7 over, I get t equals 7, and I subtract the 3 over, I get t equals negative 3. And so those are my two answers. And I'm expecting 2 answers because my highest exponent here is a 2. That's telling me how many total solutions I am going to end up with. Okay. All right, so again, right, we're looking at this next one. It's a little bit of a story problem, but not fully, because it's giving you your equation, this function that you need to know in order to do this. You don't have to make that up, right? But it says, a rocket is launched from 528 feet above sea level. Its height as a function of time t, oops, I should put in seconds, is given by this formula here, right? This function. When does the rocket hit the ground after it is launched? All right, well, when it's saying when will it hit the ground, we're saying that our height here is going to be 0. So in place of that h of t, we're going to be putting a 0 there and then solving it. Okay. So when I do that, I want to first of all look and see if there's a greatest common factor. And oftentimes on these problems there will be, and oftentimes it is negative 16 as that greatest common factor. So let's look and see if that's the case. So I have 0 equals, right, because that's my 0 equals. Let's factor out a negative 16. And so that's going to leave me with t squared. And then we got to figure out on our calculator what is 128 divided by negative 16. And that's going to give me negative 8. So I've got negative 8t. And then I'm going to take my 528 and divide it by negative 16 also. And that will give me negative 33. Okay. And now we can factor this further. right? Here's a trinomial that we can factor even more. So let's think how this would factor. What multiplies to be negative 33 that adds to be negative 8? All right, well, 33 is 3 times 11, right? And 3 and 11, if I subtract those, I can end up with negative 8 if my 11 is negative. So when I factor this, here, let's see, whoops. Gotta kind of keep, oh, that's not really what I wanted to do. What happened? Okay, sorry, I need to keep that 0 there, right? So 0 equals, and then it factors to be, like I said, t plus 3 times t minus 11, right? Because 3 times negative 11 is negative 33. 3 minus 11 is negative 8. Okay, but again, you're not quite done. We got to set both of those factors equal to 0 now, and then solve it, right? So t plus 3 equals 0, and t minus 11 equals 0. So on this one, when I subtract that over, I get t equals negative 3. But we're talking about seconds, right? We're talking about time. And time can't be negative, right? We can't have a negative 3 seconds that it's going to take for that rocket to hit the ground again, right? So the other one, if we add the 11 over, we get t equals 11. And then make sure to include your units and stuff on here that you need. So remember the time that we were talking about was seconds, so 11 seconds to hit the ground. Right? And remember, word problems need word answers. So in addition to telling us what our label is there, our units, also tell what it represents. Okay? Okay, so on this one, we're trying to find our excluded values. And so when we have this rational expression like this, there's a fraction, we need to remember that we cannot divide by 0. So that means we're trying to figure out what values of x are going to make this 0, because that's what it can't be. Well, to figure that out, you've got to do factoring again, right? Factoring on almost every problem here, guys. Okay, so x times x is x squared. What multiplies to be negative 14? That adds to be 5. Well, that's going to be 7 and 2. And in order for it to be a positive 5, I need a plus 7 and a minus 2. And then I take each of those parts and I say they cannot equal 0, right? Because we can't divide by 0. So I'm going to take that x plus 7 and say it cannot equal 0. And I'm going to take that x minus 2 and say it cannot equal 0. And then solve each of these. So if I subtract that 7 over, I get x cannot be negative 7. When I add the 2 over, I see x cannot be 2. Right? And so these are the excluded values, what they can't be. But when if it asks you for, so this just wants to know what the excluded values are. So that was the answer. But if it asks for the domain, remember you've got to write it like an interval notation. And we just have to leave out these two things. So we can have things from negative infinity to negative 7. Those are all good, but notice how I have a parenthesis next to negative 7 because it can't be negative 7. Union, it can be the stuff between negative 7 and 2. So negative 7 and 2 just can't be negative 7 and 2. So again, those parentheses. And then the union there, 2 to infinity. So that would be what my domain is if it asks for it as a domain. Okay. All right. Okay, let's keep going here. probably getting tired. I've done a lot here. All right, so on this one, when we're multiplying or dividing these rational expressions, you want to make sure that you factor everything, right? Factor everything that you can, and then we'll divide out our common factors. So I'm just going to write this as one big fraction. All right, so I'm going to factor everything on the top and factor everything on the bottom. So this factors to be, we got a leading coefficient of 1, so I know I can go straight to Hippobutts. So what multiplies to be -4? That adds to be +3. Well, we know we have to have 4 and 1, and then we need a +4 and a -1. All right, so getting good at this factoring is going to be so key. All right, on this next part, all we can do on that is a greatest common factor. We can factor out a -3, and when we do that, we'll be left with x plus 1. All right, take each of those and divide it by a -3. We're left with x plus 1. All right, on this one, this is a difference of squares, and sometimes people don't see it as that, but it's a difference of squares. That's x plus 1 times x minus 1. And then this last one to factor, what multiplies to be -20, that adds to be 1. Well, it looks like it's going to be 4 and 5. And in order to end up with a -x, I'm going to need a -5 and a +4. And now, after we factor it, right, the fun part is just dividing things out that are common factors. So the whole thing, like that's in parentheses, needs to go together. So I've got an x plus 4 with an x plus 4. Those are gone. Those divide out. X minus 1s divide out. X plus 1s divide out. And so then I'm just left with a -3 on the top and x minus 5 on the bottom. And then that would be your answer. Right? So divide everything out after you've factored it. All right, so on this next one, with adding and subtracting rational expressions, we've got to get a common denominator. And you've got to work with the denominator. Okay, so on this one, I'm going to put out to the side a little note, must keep denominator. All right, where we're going to do one down here on number 13, and I'm going to write next to that one. This one is where we're going to kill off the denominator. I'm going to get rid of it. Okay, so two different things that you have to do here. Because we're not solving anything on this number 11, we are just trying to combine these together. And with any fractions, we have to have a common denominator. So let's start by factoring the bottom if it needs to be factored. So this greatest common factor of x can come out, leaving x plus 5. So I've got an x in my denominator here, and I've got an x times x plus 5 here. So that means my common denominator is going to be x times x plus 5. That has everything that we need. All right. So on this first one, we only had an x on the bottom, and we want to get it to look like this x times x plus 5, so I need to multiply this by an x plus 5, which means on the top I need to multiply that by x plus 5. All right. Okay, so let me write down here what we have. So we've got 6 times x plus 5, and then that was a minus there, right? Minus 3. All right, so the bottom is going to stay the same. We just need to figure out how to simplify the top here. So distribute this through. We get 6x plus 30, and then minus 3. So we just need to subtract that. So we've got 6x plus 27 all over x times x plus 5. And then that is your answer. Okay, that kind of looks like a 4, but that should be an x. All right, so you've got to keep the denominator. You must keep it on this. Okay. All right, and similar on this one, right? There's no equation in it. This, neither of these start with an equal sign in them, so they're not equations. Where this one does, it starts with an equal sign in it, so it's an equation. So those are the type when we can kill off the denominators, as if it's an equation. All right, so on this one, there was 2 different methods that we talked about that we could use to do this. So I'm just going to choose to do one of the methods that I like, but so on this, I'm going to treat these 2 kind of separate at first. So I'm going to look at just this top part here and get it to be one fraction, like do the subtraction here. Well, in order to do that, I need a common denominator. And so I can see I've got an x squared on that other side. So x squared is what I want to multiply by on top and bottom here. All right? Because now I will have common denominators of x squared. So when I do this, I've got x squared minus 16. Actually, let me move this up just a little more. All right, so x squared minus 16 all over just x squared. All right, it had to be the same in order to combine them together, so I keep them the same. All right, then let's look at the bottom one here. All right, again, x squared is going to be my common denominator on this one. But this time, I need to multiply the top and bottom. In order for x to become an x squared, I need to multiply the top and bottom by x. All right. And so when I do that, I'll have 7x plus 28 over x squared. All right, because again, we had to get those the same in order to combine them together. All right, now this is the part where I say, okay, take the bottom fraction and you're going to flip and multiply. All right, so I'm going to change this to be times, and let's flip it here. So x squared is on the top and 7x plus 28 is on the bottom. All right, and by flipping that upstairs, this is gone now. So let me just cross that out. So we're just working with this up here. All right, so now let's get everything factored that we can factor here. So x squared minus 16 is a difference of squares. That's going to be x minus 4 times x plus 4. And then just have x squared there. And on the bottom, x squared. And then here, just a greatest common factor of 7 can come out. Sometimes people, sometimes those easiest ones, I would say, people sometimes just like overlook. So don't overthink it, right? Look for those greatest common factors first, because that's all we can do on that. All right, and then we'll, just like we did up here, right? This is where we get to kind of just divide things out, which is fun here. So our x plus 4 on the top with my x plus 4 on the bottom, my x squared on the top and x squared on the bottom. And so then that means I am left with x minus 4 on the top and 7 on the bottom. And that will be my answer. Okay. All right. So now let's get to this solving stuff. We can see down here, right, that we have x minus 4, x plus 9, and this was always already factored for us. And we can see it's the same thing that we have over there. All right, so our LCD on this, let's write a couple of things over here. Our LCD is going to be x minus 4 times x plus 9. But also when you're solving, you've got to think about your excluded values. All right, what can x not be? Well, if we put 4 in this one, that will make that 0. So x cannot be 4. And here, if we put -9 in there, that will give us 0. So x can also not be -9. All right, and that's important to just keep in mind on there because you might have to come back to that. Oops, I thought I put cannot equal. All right, so now we're going to multiply each of these different parts by the LCD. So this whole thing needs to be multiplied by x minus 4 times x plus 9. So my x minus, oh, let's see, let's just finish doing the rest of these. So this needs to be multiplied by x minus 4 times x plus 9. And then same thing on this last one, x minus 4 times x plus 9. All right, and these are all over 1, so if it's easier for you to kind of think of this, you know, with that fraction and stuff, that'll be good. So now the next part is we're killing off the denominator, right? So I see here, I want to get rid of that x minus 4 on the bottom. Well, that will divide out with that x minus 4 on the top. That's why we multiplied it by the LCD, to make that happen. And then what we have left is 4 times x plus 9. All right, just multiply those together. All right, on this next one, I want to get rid of that x plus 9 on the bottom. It will divide out with the x plus 9 on the top. So on this part, I'm left with x times x minus 4. And then on this last part, I see x minus 4s will divide out and the x plus 9s will divide out. So there's nothing left to multiply this -8 plus 21 by. So we'll just leave that as -8x plus 21. All right, so now we still haven't done that. We haven't figured anything out yet, right? We got to solve it. We got to figure out what x is. So let's distribute through 4x plus 36. And here when I distribute the x through, get x squared minus 4x equals -8x plus 21. And again on this one, I've got an x squared term. So remember that means I'm going to be moving everything over to one side and putting the other side equal to 0. But let's first get kind of some like terms together on here, because I see that I have a 4x and a minus 4x, and those are actually going to 0 out, right? So I'm going to get rid of those. And so now I have 36 plus x squared. All right, so now let's move over. Let's add our 8x over here, and let's subtract the 21 over. All right, and I'm going to choose to write this. It's going to be best if you write it in descending order. Right? And so I'm going to start with my x squared term, so x squared, then plus 8x, and now I need to combine my 36 minus 21 together, which is going to give me plus 15. All right, and now remember, since we got rid of everything on that side, it equals 0. And then we're going to solve it just kind of like we did up here before. Got to factor this. So this is going to factor to be, so we kind of go up here, right? This is going to factor, I'm going to say what multiplies to be 15 adds to be 8. Well, that's 3 and 5, and both of them are positive. To get that had to be a positive 8. And now set both of those equal to 0 and solve. So x plus 3 equals 0 and x plus 5 equals 0. So here I just need to subtract the 3 over, x equals 3, and here subtract the 5 over, Sorry, I meant negative 3. And subtract the 5 over here, and x equals negative 5. And so those are 2 answers, right? Negative 3 and negative 5. Okay. However, we want to look and see if we came up with, like if either of these 2 answers, if we came up with 4 or if we came up with negative 9, then we'd have to like cross that one out and say, oh, it can't be that one because it's going to make the bottom 0. So just keep that in mind, that you might have to look back to those excluded values to, double check that we're not going to be dividing by 0. All right, we are getting here, guys. Oops, let's see what happened here. No. All right, so this is going to be a story problem. All right, and so definitely going to be some story problems on the exam. And oftentimes there's going to be, these type of problems, a work problem or a motion problem like we have here. Okay, so I like to set up little charts to little tables to help me organize my information. But this one says, Salvador can paddle his kayak 5 miles per hour in still water. All right. He can paddle 8 miles upstream in the same amount of time as it takes him to paddle 12 miles downstream. Determine the speed of the river's current. All right, that's what we're trying to find. And then it says make sure to use your units, correct units on there. Okay, so if we're trying to find the speed of the river's current, then I'm going to define some variables, and I'm going to say C is going to equal the speed of the current. Okay. And then let's get this set up, and it might be easier to see what else we might need on here. So we have information about distance, rate, and time. And we have information about upstream and downstream. So my distance, right, is given here, 8 miles upstream and 12 miles downstream. And then my rate, this is the tricky part that a lot of times people forget, is that when we are dealing with the rate, it's the speed of the boat plus or minus the speed of the current. Okay, so be really careful with this. All right, so when I'm looking at my rate, I know that he is, like the boat speed on this one is 5 miles per hour. All right, so that's going to be 5. But my current speed is what I don't know. That's why I was defining a variable, saying, okay, that's what I'm trying to find. So here, my current is going to be C. So when I fill in my rate, I'm going to have 5 plus C for one of them and 5 minus C for the other. Well, upstream, you're going against the current. So that's actually making you go slower. So that's where we're going to use the minus. So 5 minus C. And then going downstream, that's pushing you faster. So 5 plus C. And then the time, all we know about the time is it says the same amount of time. And in math, when we're talking about the same, we mean that they're equal. So we got to set these equal to each other. Well, it doesn't tell me like how many hours. It doesn't say like 4 hours and 3 hours or whatever. And so what we need to do here is, and we talked about this before, when we have the formula distance equals rate times time, I need to solve this for time. So if I divide by rate, All right, then I can get time by itself. So my distance divided by my rate gives me my time. Well, we know things about the distance. That's 8 divided by my rate, which is 5 minus c. And then again on the other one, distance divided by rate, my distance is 12 divided by my rate is 5 plus c. All right, and now these have to be the same, so we got to put them equal to each other. So down here, I'll have 8 over 5 minus c equals 12 over 5 plus c. And now, just when we're solving rational equations, we've got to kill off the denominators by multiplying by the LCD. And the LCD has to be made up of both things that are in the denominator. So on this one, I'm going to multiply this by 5 minus c, 5 plus c. And then this side as well. Right, so that one's being multiplied there, and this one's being multiplied by 5 minus c times 5 plus c. So that we can kill off that denominator, those denominators. So 5 minus c's divide out there, 5 plus c's divide out here, and then I'm left with 8 times, I still have that 5 plus c equals 12 times, what's left is the 5 minus c. And then we just need to solve it from here. So most of the time I think people think, next step, let's distribute those through. That's a great next step. So we've got 40 plus 8c equals 60 minus 12c. Let's get our c's on one side and our whole numbers on the other. So I'm going to add the 12c over this way. And then I'm going to subtract the 40 over this way. All right, so when I do that, I'm sorry, this is kind of a mess here, right? Those things are gone. So when I add these together, my c's, there, I get 20c equals, and then 60 minus 40 is 20. And then if I divide both sides by 20, I get c equals 1. So the current speed, the speed of the current is 1 miles per hour. All right. And then again, I'd write it down as a word answer. 1 mile per hour is the speed of the current. Okay. All right, and make sure that answer, the speed of the current, is less than, like how fast he can paddle. Like if the current speed is 8 miles per hour or something, and he can only paddle 5 miles per hour, he is not going to be going upstream, right? He's not going to be able to make it. So that current speed needs to be smaller. Just when you're kind of thinking over, does my answer make sense? All right, work problems, right? Juan can paint a room in 9 hours. With Vanessa, they can paint the same room together in 5 hours. How long would it take Vanessa to paint the room alone? All right, so this is where we're going to talk about, job done per hour. All right, so on this one, he can paint a room. That's the job, so we can do one job in 9 hours. Okay. Now, I don't know what Vanessa's is, right? That's what I'm trying to find. How long is it going to take Vanessa alone? So I'm going to write this as 1 over V, because I don't know how long it's going to take her. And then it always has to equal out to be the time together that they can do it. So together they can do the one job in 5 hours if they're working together. And now, just like we did before, we got to multiply every single part by the LCD, kill it off so that we can solve for our V. So 5 times 9 is 45 times V. So 45V is going to be my LCD. My 4s are looking really weird. All right, so let's kill these off. 9 divides into 45 5 times. V's divide out there, and 5 divides into 45 9 times. So what I'm left with, right, is no denominator. We want to kill off that denominator to make it easier to solve for. So here I'm left with 5v plus, and this was 45, sorry, that 45 looks weird, equals, what's left here is 9v. So let's subtract the 5v over. So I have 45 equals 4v, and then I just need to divide both sides by this, and also notice it says round to the nearest tenth. So we're not going to leave it as a fraction. We're going to do 45 divided by 4 is, it's 11.25, but if we round it to the nearest tenth, that's going to be v equals 11.3 hours. For Vanessa alone, right, to do this alone. And it makes, sense that her answer, or her number of hours that she works, is more than the time it would take them to work together, right? And remember that together one always needs to be by itself on the other side of the thing here, so you're going to think about the two people, Juan and Vanessa, and then together. We're setting it up. Okay, we just did the polynomial, long division and synthetic division, so I might skip over those right now and just go to these last couple of problems so we can get through this. So on this one, where we're trying to solve for m, right, solve for m. So we're trying to rearrange this so we can get m equals something. So, like we've done before, in order to kill off these denominators and solve for m, we need to multiply each part by the LCD. And the LCD on this is just going to be x times y times m. So do that on every single part. X, y, m, x, y, m. Right? And these are over 1. So again, like if it helps you to think about this, those are on the top and 1's on the bottom. So let's divide out what we can. Those x's need to divide out on that one. The y, we've got to kill off that denominator, kill off that m there. All right, and so now let's see what we're left with. All right, here I have ym times 2, so that's 2ym, right, equals, well, we're left with an xm on this one, so equals 7xm, and then plus 5xy is what's left there. All right, and let's go back and remind ourselves we're solving for m. I see that m shows up in 2 different places here. So if that happens, I've got to get those together on the same side of the equation, because the only way to get these together as one variable is we've got to do some factoring. So let's start by subtracting that 7xm over. Oops. And so then that's going to give us 2ym minus 7xm equals, all that's left now on this side is 5xy. All right, and here, now I can see, all right, m is my greatest common factor. So let's factor that out. And that's going to leave me with 2y minus 7x. And then to get m by itself, it's connected to all of this by multiplication. So let's just divide both sides by 2y minus 7x. And then that is your answer, right? Those divide out, and we're left with just m, which is what we were trying to do. Okay. So you might need to use factoring on the problem that's on the exam. If the m shows up in more than one place, get them on the same side, factor out that greatest common factor. Okay, last two problems here. These were in Module 3 when we talked about different types of functions, how to find the different parts of them and how to graph them. So this first one is given in vertex form. And remember, in vertex form, we like it because it's easy to find the vertex. But be careful with it, right? Because insiders are liars. So if what's inside the parentheses like this, we've got to do the opposite of it. So my x-coordinate on this is not going to be 1, but it's going to be -1. And then this one is not inside parentheses, so that one stays as it is. So the vertex is -1, 2. Right. Okay, now our line of symmetry is always going to be that vertical line that goes through the vertex. And it's always going to be whatever our x is there. So our line is x equals -1. And then our y-intercept, to find y-intercept, we let x be 0 and solve for y. So remember, this f of x is really y. So if I put this down here, y equals 0 plus 1 squared plus 2. Well, 0 plus 1 is just 1. 1 squared is 1. So I've got y equals 1 plus 2. So y equals 3. And make sure you write your y-intercept as an ordered pair. All right, our x, we put x as 0. So we got 0 in place of our x-coordinate and 3 in our place of our y-coordinate. All right, so make sure you know how to do those, and then you could take that information and graph it on a grid. Just make sure you know that. Okay, last one here. So it's asking us to find these different things, and then we're going to use those to graph it. So this time, our equation is written in intercept form. And we like intercept form because it's easy to find our x-intercepts. All right, and just like I talked about up here, insiders are liars, that's the same thing that we got to think about here. So one of my x-intercepts is going to be -4. And so that's going to be -4, 0. And my other one is going to be +2 because insiders are liars, 2, 0. Okay? Because really what we're doing here, is we're letting y be 0, like this whole thing is 0, and then solving those for x's. That's how I'm getting that -4 and +2. Okay, our line of symmetry. So remember with a parabola, I'm just going to draw a really rough sketch up here. All right, if I have a parabola, and those are my x-intercepts, the line of symmetry is exactly halfway in between those two x-intercepts. So to find my line of symmetry, I need to take these x values and find the average of them. So I'm going to take because here, right, I've got x is -4, and here x is 2. So if I add those together, -4 plus 2, and then divide it by 2, because there's two things that I'm trying to average. So that gives me -2 over 2, which is -1. So my line of symmetry, right, it's always going to be an x equals something. Make sure to write it as an equation. If you just put -1 for your answer here, you're going to miss points. It needs to be an equation, x equals -1. All right, and now our vertex, well, that line of symmetry gives me part of my vertex. Remember, like we were kind of talking about it here? So that's my x value of my vertex. To find my y value, I just need to put -1 back up into that original equation there. So let me do this. So if I have y equals, so I'm going back to this, x plus 4, so in place of x, I'm going to put the -1 plus 4, and then times x minus 2, so -1 minus 2. So let's simplify this. That's 3. Here we've got -3, so y equals -9. So when x is -1, y is -9. That is my vertex. Okay, and then with my y-intercept, like I said, like we did up here, all right, we're going to let x be 0 and solve it for y. So y equals, put 0 plus 4 times 0 minus 2. So when I do that, I have 4 times -2, so y equals -8. But again, write that as a y-intercept, or sorry, as an ordered pair. So we let x be 0, and we solved y to be -8. Okay, and then you'll just graph all of those things on a grid and solve it from there. Let me see if I have a little bit of room down here to do that. So let's see here. All right, so let's graph some of these points on here. The -4, 0 is here. 2, 0 right here. My line of symmetry is x equals -1, so that's going to be this line right here through. My vertex is -1, 9, right? And remember, my vertex should be right on that line of symmetry. So that is here. And then my y-intercept is 0, -8, which is here. And then I can kind of see the shape of my graph, right? I should be a parabola. It should be a right side up parabola because there's not a negative out in the front of this, right? If there was a negative there, that would tell us it's upside down. But because that is positive, we know that it's going to be a right side up parabola. And so that is what we'll have. All right, well, I hope that is helpful for you on these. Like I said, I am going to be, like on spring break next week, so I will be reachable periodically, so I'll check my emails and stuff periodically, but hopefully this will give you a good start in being able to get ready for the exam. But if you do have some questions that come up, please send me a message to my Canvas inbox and I will get back to you as soon as I can. The exam is going to be the week after spring break. Remember, you have March 17th, March 18th, and March 19th to take that exam in the testing center. Please, please, please get it scheduled right away so you can get the time and date that you would like to take it. Okay. All right. Have a wonderful rest of your day, and I will see you again. We won't be holding the Zoom sessions next week, so I will see you on the 17th, and we'll start going over some stuff from Module 5.